Hello everyone, in this tutorial we will spawn multiple vehicles with vehicle AI component to create the traffic system. Go to map sample road network and we can delete this vehicle. Go to vehicle AI, add blueprint, actor, BP, traffic manager, and add another blueprint interface, BPI, traffic manager. Open BPI traffic manager. And rename this function to arrive at destination. Add input vehicle actor. And actor type. This object reference. Compile and save. Go to BP traffic manager. Go to event graph. In this begin play, we create a sequence. Get actor of class. Road actor. So we get the road actor from the scene. And then promote to variable road actor. All is valid. If it's valid, we found the vehicle by create a new custom event. Name it found vehicles. Compile. Call found vehicles. If it's not valid, print string. Change color to red. No road actor was found. Then get actor of class. BP fly pound. Set variable. Name is fly pound. Add new function. Get a random location on roads. Input right offset. add local variable, input key, float, line index, integer, random location, vector, spline direction, vector, and spline location. Random float, and set input key. Get route actor, get spline components, length, subtract with 1. For random integer in range. Set spline index. Get route actor, get spline component, get a copy, and get it from this spline index. Check if it's valid. If it is valid, we get tangent at spline input, get key input, world coordinate space, get location at spline input, get key input, world coordinate space, normalize this tangent, and set it to spline direction. And then set this to spline location. And this input key, we get it from 0 to 1 randomly. And get right offset from input, create a branch, get spline direction, and call cross product, get vector app, multiply with road actor, road width, divide by -4. And add it with this spline location. Then set it to random location. If it falls, we set this spline location to random location directly. without offset to the right. Then call return node. At output, vector, and this is location, rotation, rotator. Name this rotation. Get random location, line direction, rotation from X vector, connect to rotation. And here we have this get random location on roads. To event graph, found vehicles, we do for loop, variable is num vehicle. This is the number of vehicles that will spawn in the road network, and we can set this public. Num vehicles subtract with 1. Last index. Create a custom event. Name it respawn vehicle. Get random location on roads, and we offset it to right offset. Call spear trace for objects. Start location and add location. The radius is 500. Make array. World dynamic. We do this spear trace because we want to check if it overlaps with other vehicles after we spawn one vehicle. Create a branch. A variable is respawn name. Increment in. Respawn name less than 4. Create a branch. And if it's true, we respawn vehicle. And if it false, we spawn actor from class. And if this false, we spawn actor from class. We can comment on this. Press C. Try to find better found position. And we can split this found transform. This is the spawn location and rotation. And we can change this to try to adjust location, but always spawn. this class, we can add variable. Name is we call classes, and change this to actor class reference. Create array, get vehicle classes, get length, subtract with 1, call random integer in range from 0 to max, and we get a copy. So we randomly select the vehicle from this vehicle classes array. Then call is valid. Set respawn number to 0 after we spawn it, and add variable we call actors, and this variable type is actor object reference. Actor object reference. Get we call actors and add to the array. And we compile. Let's set this name vehicles to 5 to spawn 5 vehicles, and go to map. We can add this BP traffic manager to the scene, because when we need to spawn the traffic, we need to add this BP traffic manager. You can add it anywhere, and let's play this. We don't have vehicle AI component because we need to set the vehicle classes. Add classes and choose vehicle BP vehicle 6 and run again. Now you can see this is the vehicle that we spawned in the scene. There are 5 vehicles. Next, we go to BP traffic manager and add another function. This function name is get random target location on roads. We can copy this random key and random index. Promote to local variable. Next, get road actor. Get spline components. Get a copy. Get spline index. And call is valid. Get input key. Get location at line input key. where location at local variable is spline location. Vector single. Set spline location. And we return this location. And name this output is location. So it is just the location that we get from the spline component randomly. Next, we go to vehicle AI component, add variable. This variable name is traffic manager. BP traffic manager. Object reference, compile. Go to traffic manager, go to event graph, and create a custom event. This event name is set target location. Add variables. We call index. This is integer. And we call index set to 0. Get we call index less than. Get we call actors and length. If this we call index less than this we call actor length, we stop set the target location. Create a branch. If it's true, we delay 0.2. Get random target location on roads. Get vehicle actors. Get a copy. Vehicle index. Get components by class. Vehicle AI component. Get component by class. Vehicle AI component. It's valid. Then we set traffic manager. This traffic manager is safe because this is the traffic manager blueprint. And we call go to target location. And this location we get randomly. And we add this we call index. Loop it back to this branch. Double click. We need to call this custom event set target location after we complete spawn the vehicles. Set target location and run this. Now you can see the vehicle will set the target location. We need to call set target location again when the vehicle arrives at this target location. Go to vehicle AI component, add a new function. This function name is line trace for road actor. Input is actor. Vehicle actor. Get actor location. Multi-line trace for objects. This is start location. Subtract with Z 1000 at location. And this object type make array was static. This out hit for each loop bit break. The break hit result and hit actor, get tag, get a copy of this tag if it equal to road actor. And this actor we cast to road actor. Add a local variable, hit road actor. Boolean set to true. Set road network. And we break this loop when we detect the road network. After complete, we return get hit road actor and name this to hit. So we have this line trace that trace for the road actor. Go to traffic manager, setting, add the blueprint interface, BPI traffic manager. We can see this interface. We have arrived at destination. Double click on it to create this interface event. this we call actor get component by class. We call AI component is valid. If it's true, and we call line trace for road actor. If the vehicle on the road actor, and this is vehicle actor, and create variable. This variable name is hit road actor boolean. That is get a random location on roads. Call go to target location in vehicle AI component. This is the location. Go to vehicle AI component event graph and go to final target arrival, reach final target. This sequence, we get traffic manager if it is valid. Get this traffic manager to call arrive at destination and get vehicle actor. So when we arrive at the target, final target, we call this arrive at destination event, and then we call go to target location. Let's play this. And we see the vehicle drive to the target. And when this vehicle arrives at this target location, it creates another target and drive to the new target. But now we have the problem because we have this loop for our path. So it can create the problem for the traffic to drive smoothly. We can close this project. Go to plugin, we call AI source, we call AI public, BP library, and move this A grid library into this BP library folder. We call AI BP library. The same with this CPP file. Remove it. To this public and move to BP library. Go to vehicle AI, traffic tutorial, delete.vs, binary, derived data, intermediate, style, .vs config, .sln, and we generate Visual Studio project. Open traffic tutorial.sln. Go to plugin, source, vehicle AI, road network tool, road actor.h, and road actor.cpp. This road actor.cpp, this a start step library will have the error because we already changed the location. So name it bp library plus a start step library.h. The same with vehicle AI BP library. BP library. And we can run this. After you open the project, you can go to Edit, Project Setting, Map and Modes. Map, Sample Road Network, and Map, Sample Road Network. We can save all this. And we close the project. I will put the link in the description so you can download this file of code. Open it. Spline point utilities .h and Spline point utility.cpp. I create 3 new functions is find line intersection, streamline intersection, and line segment intersection. So we can open in this project. Line point utilities. Copy these 3 functions. And paste it. From this find line intersection. Copy. And save. Close this. Next, go to road actor.h. Void this apply right offset to path node. We change it to offset line points. And this is line point. And vector reference previous right vector. Save. Copy this. Go to road actor. And paste it here. We can delete all of this and rewrite it again. For in 32, j equals 0, j less than spline points dot name subtract with 1 plus j and vector current location equal line points j and vector next location equal line points j plus 1. And vector forward vector equal current location subtract with next location. Get shape normal. And vector right vector equal F vector of cross product between forward vector F vector F get shape normal. Line points plus equal right vector plus multiply with width divided by 4 and previous right vector equal right vector. If line points is empty and not previous right vector is 0, line points plus and equal previous right vector multiply with width divided by 4. Save this. Go to roadactor.h, refine path with spline points, and we add another input is load with roadactor. Refine path with spline points and load with create T array of a vector previous line points bool is at spline equal to false. Is at spline equal to true. If spline component is valid, we can delete this and name this as current line points. F vector previous right vector equal 0 vector. Offset line points current line point with previous right vector. If not previous line points is empty, F vector intersection point bool has intersection equal line point utility trim line intersection. So we trim the intersection of the spline point. Previous line points, current line points, intersection point. Path locations, append previous line points. If is at spline is true, at locations append current line point. So if this is the last line in the loop, we append the current line point and we set previous spline point for current spline point. We set this so we can continue to find the intersection point again and trim that array before we append to path location array as the result. This find path road network adjust spline nodes. If right offset is true, we don't need this. Create this as T array, F vector, adjust path. And we need another input is road width. After that, we call AI BP library. And merge close points. Adjust add 200. And save this. And we can run this project. Open vehicle AI component. Go to event graph. Go to create road network. And this array, we check this length. Greater than 1. Create a branch. And if it's true, we set this final target location. If it false, call reach final target. So when we reach final target, we call this arrive at destination to the traffic manager. And let's play this. You can see that our path don't have this loop, and it is the straight path. Go to vehicle AI component, event graph, update target location. We delete this vehicle mode because we don't have this mode yet. This follow player, delete it. And delete this go to target location. Close. Go to road actor. This find path road network. Add another input boolean. B path to target. Go to road actor. Boolean B path to target. And this add points. We check if path to target if path name greater than 0. And we add this L U A star step library a star step finding this start location target location and path. Open vehicle AI component. Go to target location. We can add another input. Is path to target. Add variable path to target. And then set this variable path to target. Create a road network path. Get path to target and set to this find path road network. In BP flight path, this go to target location. We set path to target to true. When we call set path to target to false, this find path road network only create the path location along the road. We don't connect the vehicle to the road network, and from the road network to the target location that is outside the road network. Go to event graph. When we generate path spline, we create another print string. Name avoiding obstacle. Compile. Now we need to measure the performance of this algorithm. So we will optimize it. We play this and click Start Tracing. When we want to stop tracing, we click on this Stop Tracing. Go to and stop playing. Go to Unreal Inside Session Browser. And I do the tracing before, so we can delete this. Name this before optimization. Before optimize. And open. This Unreal Inside will create the graph for us. And we have the print string to know the location when we call avoiding spline function. Double click on it, and this location, it marks the location of this print string. And you can see this analyze and map obstacle, it takes 161 milliseconds. So it is unacceptable. And it's caused by speedtry script function, 136 milliseconds, and find candidate target location, 19.5 milliseconds. Because in this speedtry script, we have a lot of function to trace the obstacle location, and we have a lot of calculation for the cell value. Let's close this. I will put the link in the description so you can download this code. Copy vehicle AI component base.h. Go to plugin vehicle AI and add this vehicle AI component base. And vehicle AI component base.cpp. This vehicle AI component base will use as the parent of our vehicle AI component. So we can call C++ function for this component. We generate this again. Open traffic tutorial.sln. So I move the function from blueprint to C++ and rewrite it again. I trace grid cell value, evaluate candidate to target. And this get cell value from road. This multi-evaluate candidate to target. We use for, which is the multithread function, instead of using for loop. When we use multithread function, it split independent workload to multiple CPU cores. The same with multithread grid cell value. We use for to do vertical line trace for grid and calculate the value of the grid cell. And this find closest point with index, we write in C++, it is faster than blueprint. And we run this. Open vehicle AI component. Go to Beatrice grid. And we can delete all of this because we will use C++ function. Create a sequence. Rename this variable to grid location. And this variable to grid values. This output name, grid locations, grid values. And remove this input, compile, and disconnect this input. And this function, we can rename it to this find candidate target location to find base target location. And disconnect this. Start location. Open it. And we delete all of this. Don't delete this find base at index. Expand node. And delete this. Disconnect. And this we collab two function. The function name is find base path index. Create local variable. This closest index local variable. Candidate indices. Delete it. And create input. This input name is indices. After that, we return get closest index as base index. This is base index. And valid index. Return has base index. Out. Save. Go to find base target. This local variable, we delete all this local variable. Out. Go to grid control. Delete get grid cell value from row. Delete this function. Get grid cell value from path. Get grid cell value near obstacle. And terrain handling. Delete vertical line trace for grid. Delete get grid cell value from terrain. Palette. Go to class setting and we change the parent class to we call AI component base. Palette. It compile successful. Go to peer trace grid and this find nearest location. We can search for function find closest point with index. This function is from vehicle AI component base. And reconnect this. Delete. Compile. We go to speed trace grid function. And we delete all of these local variable. Only left with path locations and debug previous path. Delete row location. Index with index, grid value, grid location, row hit, floor hit. Next, we disconnect this. And the sequence we add pin. Call multi thread grid cell value. Get grid center location function. Get path locations from local variable. And set grid locations. Get debug grid. Create a branch. Get grid location. And when we enable debug grid, we draw debug sphere for all the grid for each loop. Get grid value. Get a copy of this index. Is valid index. Create a branch in loop body. And we draw debug sphere when it's true. And array element is the center. Map range clamp from 0 to 2. And the range out range is 120 to 0. Then XSV to RGB. S is 1, V 1, and A is 1. Connect to this color. Duration is 1, thickness is 1. Radius 25. Next, we return this grid location and grid value. In find by target location, we call multi evaluate candidates to target and connect this grid. Get grid locations, get grid values, default line, start location, and we find base path index from this candidate indices. After that, we return base index and hash target location, get grid locations, get a copy by this base index to target location. We can search for tracing height because we already have it in C++ in vehicle AI component base. So we delete this tracing height. Before we delete, we can search for reference first by class member. Tracing height 0. Get tracing height and connect this and delete this. Okay. This get tracing height. Compile and we delete tracing height 0. Next, search for grid center. Grid center location. Find reference by class member. This grid center location, we switch it to we call actor location. Get vehicle actor. Get actor location. Like this. And copy it. Paste this. And we compile it. Let's run this project. And it is working. Now we do the tracing again. We can stop tracing and stop this. Go to Unreal Inside. Rename this to After Optimize. And open it. Go to Avoiding Obstacle. On Game Thread. And if we compare to the last, this before optimize, we can compare this avoiding obstacle. This speed trace grid is 136 milliseconds, and now it is half of a millisecond. And find base target location 1.4 millisecond now. Before it is 18.9 millisecond. So it improved this analyze and map obstacle from 159 millisecond to 6.6 millisecond. Search for traffic manager. Now we can increase this number of vehicles to 30. Let's run. And go to vehicle AI component. We can delete this print string and run this. We can handle 30 vehicles or more than this. We close the project and open splineroad.h and splineroad.cpp. This use function add spline mesh component in sort priority and copy it and change this to sort priority with integer, because we will handle multiple spline, not only two options. Sort priority. Save and we run this. Go to primary path and we don't have this primary path. Now event graph. Go to target location and input. Its input name is trigger by player. Add variable. This variable name is trigger by player. And set this variable. Move this a little bit. When we trigger by player, we set this variable to true. So go to BP fly pound. This go to target location. We trigger by player. When we do the left mouse click, add another variable. This variable name is debug spline mesh. Go to spawn default spline. After we spawn new spline, we set it to default spline. Set it first. We call sequence Get debug spline mesh. Create a branch. Get default. We add spline mesh component. So get default spline. And this is the target. If it's true, get path to target, like integer from 1 if it's true and 0 if it's false. Next, we set the color of the spline. Get trigger by player and boolean. Get traffic manager is valid. And create a branch. Get default spline. Get material instant. Set vector parameter value. Set parameter name is color. Change the color to red. And this sequence, new target location, and spline actor is not valid. We reset default spline. If it falls, we set avoiding obstacle to fall and highest input key to 0. To spawn avoiding obstacle spline, this spline actor, disconnect this, and we delete this command. Create a sequence. Get spline actor next to spline. Get debug spline mesh. Create a branch. When it's true, we add the priority. This spline mesh component. And spline actor, okay. The priority is 2. So this value is the highest, means it have the highest priority. And connect this. This material instant for is valid. We can connect this. File and save. Now this debug spline mesh is false When we set to false, when we don't want to show the spline mesh component, we don't want to show the spline mesh, the part of the vehicle, like this. And you say that we don't have the blue and green mesh on the spline. We can enable this debug spline mesh. Enable, play. If we press tab, we select on one vehicle, and we can set the target location, and the spline will have the red color. Here is the red color of this vehicle. So this system, we can control any vehicle. In this tutorial, our vehicle still have a very chaos pathfinding to avoid the obstacle movement. We will improve this traffic flow in the next tutorial. Thank you very much for watching. If you like this tutorial, please hit like and please subscribe to my YouTube channel. Thank you very much for my patrons member who are supporting me. Your support really means a lot to me. See you in the next tutorial.